All right, guys, lesson number 55. A hawk is flying horizontally at 10 meters per second in a straight line, 200 meters above the ground. A mouse it has been carrying struggles free from its talons. The hawk continues on its path for the same speed for 2 seconds. Before attempting to retrieve its prey, to accomplish the retrieval, it dives in a straight line at a constant speed and recaptures the mouse 3 meters above the ground. All right, so assuming no air resistance, X on the mouse, find the diving speed of the hawk. Okay, so let's draw this. So you have a hawk, and the hawk is 200 meters above the ground. And you have a mouse that's going to get freed. And the hawk is traveling at the speed of 10 meters per second horizontally. And right after it gets freed, this mouse is going to travel this pathway. And the hawk is going to be right above, 200 meters above. In fact, let's find that. Let's find out how far that is, which you could easily do that. You could just say that that's, what is that? So that's going to be y equals gt squared over 2, 9.8 divided by 2 times 2 seconds square. So 9.8 times, well, it's just 9.8 times 2. So that's going to be 200 minus that. So that's going to be here at 180.4 meters. I don't know if this is going to be needed for this problem, but let me see. All right. So anyways, the mouse is going to continue to travel until it reaches 3 meters above the ground. So this is going to be 3 meters. And this horizontal distance, is going to be, before we do that, let's find the time it takes for here to here. So this would be 2 seconds for that to travel at that. And so let's do this. Let's take the output to be 3 meters. And let's take the initial input to be 200 meters minus 9.8 meters per second squared divided by 2 times t squared. So let's solve for that. So the time it takes for the from here to here would be 6.34 seconds. So I'm going to say that the interval here between that delta t, which is going to be 4.34 seconds, I'm going to multiply that by so the question for part A, let's answer that, is asking, assume no air resistance acts on the mouse, find the diving speed of the hawk. All right, so in order to get that, let's find the angle, because it's gonna go right in a straight line. So we need to find the time it takes for that. So let's find this x here. So that's just going to be 10 meters per second times that. 10 times, so 6 minus 2, 10 times that. Oh my god, so this is going to be 43.41 meters. So I think we're done. I think that's it. So this is going to be at 200 meters over 43 point thing. So let's get that angle. So this angle right here is going to be 43. That's going to be visually it would look like this. It would be 200 minus 3 would be the output. So let me write that down. So that's 197 or or let me see. So 10 inverse of that divided by, is that right? Let me see. Because this would be 43.41 meters, and then this output here would be 197 meters. So this would be the opposite over the adjacent. So maybe it's so I'm gonna find that angle. So that angle here is going to be, well, I already kind of put this a little backwards here, but that's all right. I'm just going to take 90 minus that to get that. So this would be 77.5, and the time it takes for this point to go from here to here is approximately 4.34 seconds. So I am going to just do the Pythagorean theorem, and to get that speed. So this hawk would have to travel that, and that distance that it would have to travel would be about 201.72 meters. So in order to get that speed, we're going to take that distance that it would have to travel divided by the time it takes, which is 4.34 seconds. So did I store that? I don't think I did. That's okay. So 6 minus 2. 2 divided by that. So the speed here would have to travel 45.96 meters per second. And the angle here would be theta, be 77.6 degrees. And how long did the mouse take to? So that time is going to be 6.34 seconds. All right, forgive me, folks. I do suck at explaining and everything. I really don't know how to. This was kind of a hard problem, but I hope this makes sense to you guys. All right.